For this problem, we'll notice something right off the bat. Our polynomial is larger than the examples we've seen in the past. This is an x to the fourth. It's a fourth degree polynomial. That's fine. We're just going to have an additional number in our synthetic division lineup, but we'll go through it and it'll work out just as well. So let's get through that, and then you'll see at the end, for this specific example, we have another thing going on, which we also have to look out for in all of our problems, even if it's not an x to the fourth. So there's two things we're looking at in this example. One is how we can have a larger polynomial than an x cubed polynomial. We can do it for the fourth or fifth or sixth or whatever. We just have to make sure we take all the coefficients. And the second thing at the end, which I'll get to when we get there. Step one, take the numbers. 1x to the fourth, 3x cubed, 7x squared, 26x, and 15. We get all of our numbers, and we write our synthetic division bar with our remainder spot. Step 2, set our divisor equal to 0. And solve. X equals 3 means our multiplier is -3. Excuse me, -3. Alright, here we go. Step 3. Start by dropping the 1. Multiply into the next spot. Add down. We get a 0. It's the first 0 we've ever seen down here. We're going to work with it. It's fine. We still go about the same process. Multiply. -3 times 0 is 0. Goes here. No worries. Add down. 7. Multiply. -21. Add down. +5. Multiply. -15. Add down. 0. Nice clean remainder of 0. So remember I said there was something towards the end we were going to get to? That's this 0 here. So whenever we're dividing through a large polynomial, what we always have to do to our answers in the step 4 when we're putting our x's in is start with one less degree than we have here with our first coefficient. So we have an x to the 4th degree polynomial. So our solution here is going to start as an x to the 3rd degree. So 1x cubed. And we go down from there. The next spot is x squared. We have 0x squared. So we don't even need to write it. So this is x cubed. This is x squared. This is our x term, and that's our number. We don't have any x squared. We have a 7x. It's positive. And we have a 5. And no remainder. So the other thing that we're looking at in this example is how sometimes you get a 0 under the synthetic division bar, and that just means you don't have a term for that x value. We have 1x cubed, no x squareds, 7x, and the 5.